Good afternoon, everyone. So, today we'll be discussing 12th ESIP Maths Class Test number 2. The solution will be in two parts. Part 1 will contain first 20 questions, and the next part will contain the other 20 questions. So, we'll be discussing the test number 2, which contains 3D and vector. So, in the first question, we have been given two lines in a plane and we have to find out the direction cosine of normal. So this is the plane we have given and these are the two lines we have given L1 and L2. B1 and B2 are the direction ratio of the respective lines. So we know we have two vectors in a plane. So we can easily find out the normal vector to the plane, right? Normal vector to the plane can be easily find out b1 cross b2. So this is b1 cross b2 ijk 1 1 1 1 1 d. So we got n vector is this and this. So n vector is I minus j plus 0k divided by root 2. We have added plus minus here because the normal vector can be in both the direction upward the plane or inside the plane, right? I hope you all understand this. So n vector is plus minus I minus j plus 0k cap divided by 2 root 2. So direction cosine can be this plus minus 1 by root 2 minus 1 by root 2 comma 0. This is a very easy question. I hope you all got it. Now we will move on to the next question. We have question number 2. Question number 2 says the plane containing two lines. The lines are given. The plane containing two lines. We have given the lines. And we have to find out the equation of plane, which is written in the form of 11x plus my plus nz equals to 28. Right? So suppose we have line 1, this is line 1 and this is line 2. If you see, both the lines are both the lines are parallel, right? So we have direction ratio of the line here. We have 2 points on the line. To write the equation of a plane, we need only two things, one point on the plane and a normal vector to the plane. We already have points here, that is 3 comma 2 comma 1, and the other point is this. So we already have points. We just need a normal vector to the plane. We just need normal vector to the plane. So normal vector can be easily find out by taking a cross of two vectors in this plane. One vector we already have is this b vector and the other vector we can form joining these 2 points on the line. AB vector, right? AB vector is this and small b vector is this. So we can write the equation of plane r minus a dot n equals to 0. It is the box product of r minus a, b and ab vector, right? I hope it is fine. So this is r minus a goes into the first row, x minus 3, y minus 2, z minus 1. Small b vector is 1, minus 4 and 5. And AB vector is minus 1, minus 5 and minus 2. Their box product is 0. So we will solve this determinant, this here. So we got the equation of the plane, the required plane is 11x minus y minus 3z equals to 28. And the equation of plane which is given to us in the format 11x plus my plus nz equals to 28. We can compare these two easily. We can compare and find out the value of m and n. From here we got m equals to minus 1 and n equals to minus 3. I hope it is clear to everyone. Now we move on to the next question, question number 3. the equation of plane passing through the point 1 comma 1 comma 1 and perpendicular to these two planes, perpendicular to these two planes. So as we already know, to write the equation of plane we need a point and normal vector. We already have a point which is given to us 1 comma 1 comma 1. Suppose the point is A. All we need is normal to the plane, and they are saying that the required plane is perpendicular to two planes. Suppose the planes are P1 and P2, then normal will be N1 and N2. So we can find out the normal of the required plane by the cross of these two normals. N is N1 cross N2 vector. So we can find out N1 cross N2, which is minus 14 I cap minus 2 j cap minus 15 k cap. So now we have a point that is A, and we have a normal vector. We can easily write the equation of the plane r minus a dot n cap n vector is equals to 0. Minus 14 times x minus 1 minus 2 times y minus 1 minus 15 times z minus 1 equals to 0. So we got the equation of required plane, that is 14x plus 2y plus 15z equals to 31. I hope it is clear. Now we will move on to the next question, that is question number 4. In this, let P be the image of point 3 comma 1 comma 7. So this is the point 3 comma 1 comma 7 with respect to the plane x minus y plus z equals to 3. Then the equation of the plane passing through point P and containing the line. Okay, first we will find out the point P, that is the image of A. P is the image of A in this plane. So we can write, suppose the coordinates of P are x comma y comma z. So we can write x minus 3 upon 1 equals to y minus 1 upon minus 1 equals to z minus 7 upon 1. All right, this is equals to minus 2 times ax1 minus by1 plus 7 into 1 minus 3 divided by a square plus b square plus c square. This we all know. So we will solve it. This comes equals to minus 4. So we can solve x minus 3 upon 1 equals to minus 4. We got x equals to minus 1. Now y minus 1 equal upon minus 1 equals to minus 4. We got y equals to 5. Now z minus 7 upon 1 equals to minus 4. We got z equals to 3. So we got the coordinates of point P minus 1 comma 5 comma 3. That is the image of point A in the given plane P. All right. Now we got point P. We have to write the equation of a plane which contains P and has a line. This line, that is x upon 1 equals to y upon 2 equals to z upon 1. So this is the line. We got the point on the line, that is 0 comma 0 comma 0, and the direction ratio of the vector along the line is 1 comma 2 comma 1. So we can write the equation of line like we have a vector b vector. We can draw OP vector. The cross of these two vector will give us a normal. So we can directly write out the box product of r minus 0 OP vector and B vector is equals to 0. This is the equation of the plane. Now x, y, z, OP vector is minus 1, 5 and 3, and B vector is 1, 2 and 1. You will solve this determinant and equate it with 0. We will get this equation. If you further solve this, we get x minus 4y plus 7z equals to 0. And this is option C. Option C is correct. We move on to the next question, that is question number 5. Perpendiculars are drawn from points on the line to the plane. So this is the line. We have written a general point in parametric form on the line. Alright. And a perpendicular is drawn from the point on the line to the given plane P. P is given as x plus y plus z equals to 3. So this is perpendicular drawn from the points on the line on the plane. Alright. We have to find out the feet of perpendiculars lie on the line. So we have to find this F. This is the feet of perpendicular lies on the plane. Alright. So we can write the general point in parametric form on the line from here 2 lambda minus 2 comma minus lambda minus 1 comma 3 lambda. All right. Now foot of perpendicular, we know we can directly write the foot of perpendicular. Suppose the foot of perpendicular are x comma y comma z. So we can write x minus x1 x minus x1 upon a. A is the coefficient of x in the plane. Y minus y1 y minus y1 upon a2 and z minus z1 upon a3 is equals to minus ax1, that is 2 lambda minus 2 into 1 minus lambda minus 1 into 1 plus 3 lambda plus 3 lambda into 1 minus 3 upon a square plus b square plus c square. This is, we already know, this is simple formula we use to find out the foot of perpendicular from of a point in a plane. All right. If we solve this, we got minus 4 lambda minus 6 upon 3. Now we equate x minus 2 lambda minus 2 by 1 equals to this. So we got this, we got x equals to 2 lambda by 3. Next, we equate this with this. So y plus lambda plus 1 equals to this. We got y is equals to minus 7 lambda plus 3 by 3. And similarly, we did z minus 3 lambda upon 1 equals to minus 4 of lambda minus 6 by 3. All right. So we got our x coordinate, we got our y coordinate, we got our z coordinate. If we solve this, it can be rewritten as x upon 2 by 3, y minus 1 upon minus 7 by 3 equals to z minus 2 upon 5 by 3 equals to common lambda. All right. So we got the equation of the required line. All right. So we can see 2 by 3 minus 7 by 3, 5 by 3. These are the direction ratios. These are the direction ratios. So we can clearly see option D is the correct answer. Now the next is question number 6. In question number 6, the equation of a plane passing through the line of intersection of these two planes and at a distance of 2 by root 3 from the point 3 comma 1 comma minus. So we have to find out the equation of plane, all right, which is passing through the line of intersection. So this is the concept of family of planes. We can write the equation of all the planes which is passing through the line of intersection of two planes. Suppose the given two planes are P1 and P2. So we can write the equation of desired plane is this P1 plus lambda time P2. So this is our desired equation. If we get the value of lambda, we will get the required equation of plane. To find the value of lambda, we have been given additional information. All right. The additional information is that this plane P, this is the plane P, its distance from this point, this distance is given as 2 by root 3. 2 by root 3. This is simple distance formula. We already know the formula of this to find the distance of a point from the plane, that is d equals to ax1 plus by1 plus cz1 plus d upon root a square plus b square plus c square. Just simply apply this formula. This is ax1 plus by1 plus cz1, all right, minus d upon under root a square plus b square plus c square. Just solve it and it will and equate it with 2 by root 3, which is the distance given to us. Now we will get this. If we square both sides, lambda square upon 3 lambda square plus 4 lambda plus 14 equals to 1 by 3. So from here, we directly get the value of lambda equals to minus 7 by 2. Minus 7 by 2. And if we put the value of lambda in this equation, we will get the desired equation of plane. So we just put the lambda and we will get the equation minus 5x by 2 plus 11y by 2 minus 7 by 2 plus 17 by 2 equals to 0. We can rewrite this in the desired format, that is 5x minus 11y plus z equals to 17, and it matches with option number A. I hope it is clear. These are the kind of questions JEE asks very frequently. JEE always prefer to ask question which involves more than one concept. All right. So here in this previous question, they have asked us about the family of planes concept as well as the distance of a point from the plane. All right. So question number 7, if the lines x upon 1 equals to y upon 2 equals to z upon 3 is lambda, this is given. The line 2 x minus 1 upon y minus 2 and this z minus 4, this is line 2, and the equation of line 3. These three lines are concurrent. So the three lines are concurrent when they are passing through a common point. So if L1, L2 and L3 passes through a common point, then these three lines will be concurrent. All right. So we have to find out the condition of concurrency. All right. So we can write the coordinates on the lines in parametric form. From the line 1, the parametric coordinates will be lambda, comma 2 lambda, comma 3 lambda. So the x coordinate is lambda, y coordinate is 2 lambda, z coordinate is 3 lambda. From the line 2, we can say the x coordinate is 3 mu plus 1, y coordinate is minus mu plus 2, and z coordinate is 4 mu plus 3. All right, these are written here. And similarly, from the line 3, we will get the x coordinate 3 mu minus k, 2 mu plus 1, 2 phi plus 1, and h phi plus 2. All right. These are the coordinates x, y, and z written in parametric form. For these three lines to be concurrent, all these three x has to be same, all these y has to be same, and all these z has to be same. So on solving, now we can easily equate these two. If lambda equals to 3 mu plus 1 and 2 lambda equals to minus mu plus 2. All right, from here we got the value of mu equals to 0. You put the value of mu in any of this equation, we will get the value of lambda as well. All right, so we got mu, we got lambda. Now we can equate these two. 2 5 plus 1 equals to 2 lambda. We got the value of phi as half. All right, phi is half. So we got the value of mu, we got the value of lambda, we got the value of phi. Now we have to find out the value of h and k, right? So if we equate these two, we will easily get the value of k. 3 5 minus k equals to lambda. Lambda is equals to 1. So we got the value of k equals to half. Similarly, this is equals to this. So 3 lambda equals to h phi plus 2. So here, from here, we got the value of h equals to 2. So our option is the option D is correct answer. The value of h is 2 and the value of k is half. All right. I hope it is clear. So in this question, the concept was the concurrency of lines. So when the three lines passing through a same point, these lines can be said are concurrent. Now we will move on to the next question, that is question number 8. We have been given two lines. This is line 1 and this is line 2. And they are saying that these two lines are coplanar. So we have a direction vector in the line 1. We have the direction vector in the direction of line 2. And we have 2 points on the line 1 and line 2 respectively. We can draw a vector by joining these 2 points. Now we have 3 vectors in the plane, b1 vector, b2 vector, and this vector. We know that if three vectors are coplanar, the box product of these three vectors has to be 0. The box product of these three vectors has to be 0. Now, see, this is C vector, this is B1 vector, and this is B2 vector. The determinant of these three will be equal to 0. On solving these, we got the equation k square plus 3k equals to 0. Now we got two values of k from here, k equals to 0 or k equals to minus 3. So the answer is option C. Now we move on to the next question, question number 9. In this, we have to find the distance of point minus 1, minus 5 and minus 10, the distance of this point from the point of intersection of the line and the plane. All right, of the line and the plane. So this is the line and this is the plane. Now P is the point of intersection of the line and the plane. We can write the coordinates of P in parametric form. So we can write the coordinates as 3 lambda plus 2 equals to 4 lambda minus 1 equals to and comma 2 lambda plus 2. These are the x, y and z coordinates. And for this line to intersect this plane, these coordinates will satisfy the equation of the plane. So put these values in this equation and we are getting the value of lambda equals to 0. Value of lambda equals to 0. If we put the value of lambda in these parametric coordinates, we will get the coordinates of P, that is 2, -1 and 2. Now we got the coordinates of P. We have to find the distance of this point P from a given point on the line, that is -1, -5 and -10. We can simply use the distance formula. We all know it very well. Just apply the distance formula between these 2 points, and we are getting this distance as under root of 3 square under root of 4 square plus under root of 12 square, that is root 169, that is equals to 30. So answer for this question is option D. Now we move on to the next question, that is question number 10. In question number 10, the distance of the point 1 comma minus 2 comma 3 from the plane P, that is x minus y plus z. This is the plane, and we have to find the distance of this plane from this point, and the distance is measured parallel to the line. Suppose this is the line, that is x upon 2 equals to y upon 3 equals to z upon minus 6. This is the line. Its direction ratios are 2, 3 and minus 6. We have to find the distance of this point from this plane along this line. So these two lines are parallel. So we have to find this distance. Let's assume this coordinate is alpha comma beta comma gamma. All right, alpha, beta and gamma. Okay. Now we can write the alpha, beta, gamma in parametric form. All right. So this is alpha minus 1, this is 1, correct it, upon 1, sorry, alpha minus 1 upon 2, correct this is 1 and this is 2, equals to beta plus 2, upon 3 equals to gamma minus 3 upon minus 6 equals to lambda. Now from here we will get lambda, 2 lambda. So in this, correct this, alpha minus 1 upon 2. All right. Now alpha will be 2 lambda plus 1, 2 lambda plus 1, beta plus 2 by 3, this. Now we put the value of alpha, beta and gamma in this plane. So we will get 2 lambda plus 1 minus 3 lambda minus 2 minus 6 lambda plus 3 equals to 5. All right. And when we will solve these equations, we will get lambda equals to 1 upon 7. All right. Lambda equals to 1 upon 7. Now satisfy the value of lambda, in, and we will get alpha, beta and gamma. All right. So alpha will be 9 by 7. Beta will be minus 11 by 7. Gamma will be 15 by 7. All right. Now we got the coordinates alpha, beta, and gamma. So we can easily find out this distance d by using simply the distance formula between these 2 points. So alpha, beta, gamma is this, and this is the another point. So if you use distance formula, we get d is equals to 1. So option A is the correct answer. Next is question number 11. We have to find out the angle between the plane 2x minus y plus z equals to 6 and a plane which is perpendicular to other two planes. Suppose the other two planes are P3 and P4, all right, and we have to find out P2. And they are saying that P2 plane is perpendicular to other two planes, that is P3 and P4, which is given to us. So the normal of plane P2 can be find out equals to N3 cross N4, N3 cross N4. So we can find out N2 vector as I cap, J cap, K cap. N3 is the plane P3 is x plus y plus 2z equals to 7. So the normal vector is 1 comma 1 comma 2, and the plane P4 is x minus y equals to 3. So the normal vector is 1 minus 1 and 0. So from here we can find out that normal vector N2 is equals to 2 times I plus j minus k. All right. And now we have to find out. Now we got the N2 and we already have plane P1. So we have N1. To find out the angle between two planes is the angle between their normal. So we can find out cos theta as N1 dot N2 upon magnitude of N1 and N2. So cos theta is N1 dot N2 is 2 into 1 minus 1 into 1 and plus 1 into minus 1. So the cos theta is 0. It means theta is pi by 2. It means the angle between these two planes is pi by 2. So the planes are perpendicular planes. Option D is the correct answer. Now we move on to the next question, that is question number 12. If the angle theta between the lines x plus 1 upon 1, this y minus 1 by 2 equals to z minus 2 by 2, and the plane and the other plane is such that sine theta is 1 by 3. Suppose this is the plane we have been given and this is the line. This is the line. This is the angle between the plane and the line. This is the normal to the plane. This is the normal to the plane. So if this is theta, this angle is 90 minus theta. 90 minus theta. We know the normal vector of the plane, that is 2i cap minus j cap plus root lambda times k cap. And we also know a direction vector along the line, that is 1 comma 2 comma 2. If we take dot product between these two vectors of direction vector in this line and a normal vector, so we can write cos 90 minus theta equals to this vector b vector, this is b vector, and this is n vector. This is n vector. So cos theta is 2 into 1 minus 2 plus 2 root lambda upon root b into root n, modulus of b and modulus of n. Cos 90 minus theta is sine theta, which is given to us as 1 by 3. And this is equals to 2 root lambda upon 3 times root lambda plus 5. This cancelled out. Now if we square both sides, we got 4 lambda equals to lambda 5 plus 5, and consequently we get lambda equals to 5 by 3. This is what we had to find. So option D is the correct answer in this question. We next move on to question number 13. Next move on to question number 13. We have to find out the shortest distance between two lines. So we all know this is a very important formula. Every year, every year in IIT JEE Mains as well as Advanced, the concept of the shortest distance between two lines with its special case that shortest distance between two skew lines are asked every year. So this is very important question. This is the type of question which comes in the exam for sure. You mark it. This question will be appeared in your exam 100% sure. So we know that shortest distance formula is A2 minus A1 dot B1 cross B2 upon magnitude of B1 cross B2, right? A1 and A2 are the points on the lines and B1 and B2 are the direction vector of the line. So we know the B1 vector is 2i minus 7j plus 5k. B2 vector is given. Now we can find out B1 cross B2. That is, if we solve the determinant, we get the value of B1 cross B2 as 16 times I plus j plus k. 16 times I plus j plus k. This is B1 cross B2. We have A1 vector, that is the point on the line 1. A1 is position vector of point on the line 1, 1 comma minus 8 comma 4, and A2 vector is the position vector of point on line 2, that is 1 comma 2 comma 6. All right. So A2 minus A1, a vector, can be easily find out as this: 0 I cap plus 10 j cap plus 2k cap. Shortest distance between these two lines, just put these values in this formula. Now A2 minus A1 dot B1 cross B2. So this is 16 times 0 plus 10 plus 2 upon 16 under root 3. So the answer is 12 upon root 3. So the 4 root 3 is the final answer. All right. So mark this question very important. You will surely get to see this kind of question in your exam, both the JEE mains as well as advanced. All right. See, I understand the requirement of the exam. I myself have prepared, given the JEE advanced as well as mains, and I already also cleared this exam. My name is Nishant Lodha, and I graduated from IIT Roorkee, and I have worked in other institutes like Physics Wala, and currently I'm working in Stellar Academy at Vasco Center. So, so I understand the requirement, the core requirement of this exam. So, and this is one of the question which you should mark that it is very important. At 14, question number 14th. If the length of the perpendicular from the point, from the given point to the line, to this line is root 3 by 2. Perpendicular distance is given. So we can easily apply the formula. So first we will write a point on the line in parametric form. This can be written as lambda 1 minus lambda minus 1. Now AP vector is perpendicular to B vector. So the dot product of these two vectors will be 0. So AP is perpendicular to B vector. AP dot B will be 0. AP vector is, the dot product is lambda minus B plus 0 plus this. From here we can solve and get lambda equals to minus half. If we put the value of lambda here, we will get the coordinates of point P, that is -1 comma half comma -1, right? Now we already know this distance d, that is √3/2. If we apply the distance formula in these 2 points, we will get the value of beta. Now apply the distance formula. D is equals to beta plus half square plus -1 square plus beta plus half whole square, that is given as √3/2. If we square both sides, we will get the value of beta. Beta plus half equals to plus minus half, and beta is equals to -1 and 0. The value of beta equals to 0 will be rejected, as it is given in the question itself that beta cannot be equal to 0. So the value of beta is -1. That is option number B. Now we move on to the next question, that is question number 15. If the mirror image of the point 247 in the given plane P is ABC. So P is the point and its image in the plane P is this. This is the image. This is the image of point P. Now we can easily write the image of point P in the plane is A minus 2 upon 3, B minus 4 upon -1, C minus 7 upon 4 equals to -2 times 6 minus 4 plus 28 minus 2 upon A square plus B square plus C square. If we solve this, we get -28 upon 13. So now we can equate these three. A minus 2 by 3 equal to this, B minus 4 by -1, C minus 7 upon 4. So from here, from these two, we got A equals to -58 upon 13. And we got B equals to 80 upon 13. And similarly, we got C equals to -31 upon 13. All right. So in the question, they are asking us to find out the value of 2A plus B plus 2C plus 2C plus 2C. All right. So A is -116, B is 80 upon 13, and C is -31 into 2. So -31 into 2. -31 into 2, and this is -98 by 13, which is equals to -6. I hope this is clear. All right. So we had to find out the value of 2A plus B plus 2C, which is equals to -6. All right. Now we move on to the next question, that is question number 16. So in question number 16, let the equation of the plane that passes through the point 1 comma 4 comma -3, 1 comma 4 comma -3, and contains the line of intersection of the planes this. So this is the concept of family of plane. We can easily write the equation of required plane which is passing through the line of intersection of two planes. Suppose P1 and P2, and we can write all the planes which is passing through the line of intersection of P1 plus P1 and P2 is P1 plus lambda P2, right? So the required plane is P1 plus lambda P2 equals to 0. P1 is this one, P2 plane is here, Now P1 plus lambda P2 is this. They are further saying that this plane passes through the point 1 comma 4 comma minus 3. So just satisfy this point in this plane. So here we got the equation, that is 36 lambda minus 24 equals to 0. On further solving, we got lambda equals to 2 by 3. 2 by 3. If we put the value of lambda in this equation, we got 11x by 3, this plus 4 by 3y plus 8 by 3z minus 1 equal to 0. If we write this equation in the form of alpha x plus beta y plus gamma z plus 3 equal to 0, we can compare alpha equals to minus 1, beta equals to minus 4, gamma equals to minus 8. And they are asking us to find the value of alpha plus beta plus gamma, that is equals to minus 23. Now we move on to the next question, that is question number 17. In question 17, the perpendicular distance from origin to the plane containing two lines, all right, containing two lines. So this is line 1 and this is line 2. This is the point on line 1, 3 comma 2 comma minus 5, and this is 1 comma 4 comma minus 4 is the point on line 2. We have direction vector, that is b1 vector is 3 comma 5 comma 7, and the direction ratio of the line 2 is 1 comma 4 comma 7. Now we can write, suppose there is a point r vector and we took a point on the line, that is a vector. So r minus a dot b1 cross b2. All right, r minus a is one vector and these are two other vectors. The box product of these three vectors will be 0. If the three vectors are coplanar, then their box product is always 0. Their scalar product is always 0. So equation of plane is can be written as the box product of these three vectors equal to 0. So r minus a vector is in the row 1 x minus 1, y minus 4 and z plus 4. This is a vector. This is b1 vector. This is b1 vector. 3 I cap, 5 j cap, 7 k cap, 3, 5 and 7. Now this is b2 vector, that is 1, 4 and 7. The determinant of these will be 0 and we got the equation of the plane is x minus 2y plus 7 plus z plus 11 equal to 0. This is the equation of plane. Now they are saying that the distance of this plane from the origin, the perpendicular distance they are talking about is, that is we have to find. So we have to find the distance of this plane from origin. We can simply use the formula ax1 plus by1 plus cz1 plus d upon root a square plus b square plus c square. So this is a very trivial problem now. If we find out the distance of this plane from origin, we will easily get 11 by root 6. So the answer is option number B. Now the question number 18. The plane containing, sorry, the question number 18. The plane which bisects the line segment joining these 2 points. So these are the points A and B, and this is the line segment joining A and B. There is a plane which is bisecting this line. Bisecting means it is cutting these two lines in equal parts. It is dividing these lines in equal parts. It clearly means this point of intersection of line and the plane has to be the midpoint of this line segment. So now we can easily find out a vector as minus 3 plus 3 by 2 is 0. So the coordinates of the midpoint of these two lines can be easily find out. -3 plus 3 by 2, -3 plus 7 by 2, that is 2, 4 plus 6 by 2, that is 5. So we got the coordinates of A vector. And what do we have to find? We have to find out the first we have to find out the equation of the plane. So we already know the point in the plane. This is A vector. This is the point on the plane. If we got the normal to the plane, we can easily write the equation of the plane. And we know that if this plane is bisecting and this line segment, this vector, this AB vector, it is given that this AB vector is perpendicular to this plane. This AB vector is perpendicular to this plane. So this is the normal to the plane, 6i cap plus 10j cap plus 2k cap. All right, AB vector is this. This is normal to the plane. Now we know a point on the plane, normal to the plane. We can easily write the equation of the plane, that is r minus a dot n vector equals to 0. Equals to 0. So 6 times x minus 0 plus 10 times y minus 2 plus 2 times z minus 5 equals to 0. So this is the required equation of the plane, 3x plus 5y plus z minus 15 equals to 0. Now we have to check from the options that which of the points passing through this plane. So in the question number 18, the option D, 4 comma 1 comma minus 2 is the only point which satisfies this equation of the plane. So option D is the right answer. Now we move on to question number 19. Now we move on to question number 19. The plane which bisects the line segment joining, 19, if the plane 2x plus y minus 5z equals to 0 is rotated about its line of intersection, all right, with the plane, this by an angle of pi by 2. Okay, so this is again the concept of family of plane. So first we will write the equation of family of plane. Equation of family of plane with, that is the plane which is passing through line of intersection. So we can write p1 plus lambda p2, p1 plus lambda p2, family of plane p1 plus lambda p2 equal to 0. So we, from here we got 2 plus 3 lambda x plus this minus 7 lambda equal to 0. This is the equation of plane. And they are saying that it makes, and if it's rotated in such a way that it makes an angle of pi by 2 from the line, from the, by an angle of, if the plane this is rotated about the plane this by an angle of pi by 2. All right, so this family of plane, if it is rotated with pi by 2, this family of plane will have to make pi by 2 degree with the normal of this plane. So the angle between the normal of these two planes, the angle between the normal of these two planes is also 90 degree. These two will also be perpendicular. So if we take the dot product of these two vector, these two normal vector will be 0. So take the dot product of normal of this plane and normal of this plane. So 2 times 2 plus 3 lambda plus 1 times 1 minus lambda minus 5 times 4 lambda minus 1. If we solve this, we got the lambda equals to 2. If we put the value of lambda in this equation, we got a required plane, that is 8x minus y plus 3z minus 14 equal to 0. From options, we can check which of the coordinates are satisfying the required equation of plane. So this plane is passing through 1, 0, 2. That is option number C. Now move on to the next question, that is question number 20. The plane containing line, okay, this is the plane. It contains this line. It contains this line. Its direction ratios are 2, -1 and 3. Suppose the direction vector is b1 vector and the point on the line is 3, -2 and 1. All right. So now we can write the equation of this plane. Suppose ABC are the direction ratio of normal vector of the plane. So normal vector is ai cap plus bj cap plus ck cap. So we can directly write the equation of the plane whose normal vector is this and the points are 3, -2 and 1. A times x minus 3 plus b times y plus 2 plus c times z minus 1 equals to 0. Now the normal vector of this plane, will make an angle of 90 degree with a vector in this plane. So the normal vector is perpendicular to b1 vector. So the dot product of normal vector and b1 vector will be 0. That is 2a minus b plus 3c equals to 0. Also this normal vector will make an angle of pi by 2 with the projection of this line. The projection of line will also lie in this plane, right? Also lie in this plane. So it will also make a 90 degree angle with the plane, that is 2i cap plus 3j cap minus k cap, right? So 2a plus 3b minus c equals to 0. Now we can solve these two equations. A upon this into this. So this is a upon -8 minus b upon -8 equals to c upon 8. So the ratio of ABC is 1 is to -1 is to -1. So the if we put the value of ABC in this equation, we will get the equation of desired plane A x minus 3 b y plus 2 minus 1 z minus 1 equal to 0. The equation of plane is x minus y minus z minus 4 equals to 0. This plane passes through 2, 0, minus 2. This plane passes through 2, 0, minus 2. That is option number D. So guys, this is the end of discussion of part 1 of test 2. In the next part, we will be discussing question number 21 to question number 40. All right. I hope all the questions are clear to you. All right. Thank you.